Hello everybody. Today we're going to look at the first practice assessment. So if we look in our OneNote, we've got this practice assessment here about monitoring motors. So the time of the motor test is given to us and the amount of power that it was able to achieve is also given to us. So after 10 seconds of running the motor, the power reached 210 revolutions per minute. So I've taken that information and I've put it into an Excel spreadsheet. If I want to import this into NZ or take it anywhere else, I'm going to have to put it in an Excel spreadsheet first. But I'm going to just have a little play with it straight away here in Excel just to see what I can find out. So the question asks us to, first of all, look at these breaks up to the first 30 seconds, 30 to 60 seconds, and 60 to 90 seconds. So let's take my information and let's just put it in chunks. So I'm going to copy that and paste it there. Control C, Control V if you don't know the shortcuts. And I'm going to do a graph. So one of the nice things about doing it straight away in Excel is I don't have to import it. I don't have to do anything else with it. And there's my graph. Okay, so it looks kind of straight. There might be a slight curve to my dots. So let's try fitting a trend line. I'm going to go to one of the points. I'm going to right click. I'm going to come down to add trend line. And here are all my choices. Linear. We're not doing linear. For level 2, we're always concentrating on one of these other ones. So let us try an exponential first. Okay, and that looks pretty good. If I want to see how good, I can do an R squared on the page, and I can do an equation as well, just to see what it is I'm fitting. So R squared, 0.99, 99%. Right, let's try a polynomial. Ooh, R squared of 100%. Okay, so that looks like a good model right there. 0.3 x squared plus 7x plus 110. Okay, so that looks like a good model. I'm going to keep that one. I'm just going to put it over there for the moment. Right, the next lot of numbers they want me to do is 30 to 60. So I'm going to copy this lot first. Control C, Control V. Double click in between the lines just to expand it out. Right, I don't need 10 and 20 seconds, so I'm going to delete those and move my cells up. So there's my numbers. I could have retyped them over there, but I've just copied them and pasted them and got rid of the ones I don't need. So highlight, insert, chart, scatter. There's my next series of points. Why do I include the 30? I've already used the 30. Well, if I later on want to do a piecewise function, little bits of a graph all joined together, little pieces, then I need to include the joining point as well, because it reaches 30 here. Otherwise, it would just jump over invisible space to reach 40. So I'm including that point for my new model. Okay, right click on a point, add a trend line, and let's put the intercept and the equation in R squared straight away on the screen. So linear, no good because we're not doing linear models. Let's try polynomial. Ooh, 99%. That seems pretty good. Let's see if we can do better. Okay, power, 95%. Not as good. Exponential, 98%. And those are my choices. I can go back to my polynomial and see if an x cubed graph would be better. So if I change the power from the highest power to an x cubed power, I can achieve my 100%. If I go back down to an x squared, I might want to stay with this one. 99% is pretty good. That's a reasonable equation. So let's jump over to the very last part of that first investigation, those last few points. So I'm going to copy this again, place it over there. I'm going to double click between the lines just to expand out what I've got here a little bit. And I'm going to get rid of those first 5. Again, I want my common point included in both. Otherwise, there's going to be a jump in my piecewise graph if I decide to do that. Okay, so delete, up, there we go. So I'm going to copy those, insert chart, scatter chart. Oh, and look at this, it's a curve that starts to curve backwards. Interesting. So let's right click, let's add a trend line. Straight away I'm going to add my equation and my r squared. I'm going to bring my graph down here so it's kind of out of the way. So 92%, not a very good trend line. So going back to my trend line, let's try a polynomial. Oh, I've got 2 now, so let's delete that one. So I've just got the 1. There we go. So click on that one, my equation, my r squared. All right, let's see if we can find a different model that will perhaps give better 87%, 90%. So again, my polynomial seems to be the best, 98. If I went up to an order of 3, ooh, that's a weird looking curve, but it does give me 100%. I'm going to stick with an order of 2, an x squared graph. So I've got 3 pieces to my puzzle now. So far I've got this one with 100% fit, 99% fit, and 98% fit. Last thing I'm going to try and do is fit a curve that goes through all of my points. So I'm going to insert, chart, schematic chart, and I'm going to put in a trend line. So let's grab this down here for the moment. Go back to my trend line. Linear is no good. Let's try a polynomial. Oh, equation in r squared. Okay, 96%. Oh, 71%. That's pretty awful. 97%. But just looking at it, it goes way off the chart there. Doesn't even hit my 6,000. Let's try a power. 93%. The polynomial seems to be the best one, 96%. But again, 1, 2, let's count 1, 2, 3, 4, 5, 6 points are not on the line. Probably even 7 points given that one. So that's the best fit I can do. If I went up with my powers, it's going to start to fit a bit better. There's a really nice one, power of 4. The highest power there is an x to the power of 4. That fits much nicer. I think I'm only allowed x squared. I'll have to double check on that one, but those are some of the trend lines. So I have fitted 3 different lines to 3 points there. I might throw in a log one here, just so all my graphs are not, or throw in an exponential. So all my graphs are not just graphs that are x squared graphs, just for a bit of difference. If I could find something else for this trend line, this would be also good, but it seems my polynomial is the best on that one, my quadratic equation on that particular occasion. All right, so that is the first part of practice 1. That is well and truly enough skills there for my achieved. I have produced graphs, I've fitted models, and I can even give a bit of conversation about why it is a good model or why it's not such a good model. Thank you very much, everybody. And next time we will look at the second part of that assessment. Catch you next time.